Well, hello, everybody, and welcome to day 2 or lesson 2 of Unit 16 sequence series. Today we're going to be dealing with arithmetic sequences. I know it looks like the word arithmetic because it is the word arithmetic, but when dealing with sequence and series, it's pronounced arithmetic. Okay, so what is an arithmetic sequence, first off? You're looking at one. Hey, you're looking at it. An arithmetic sequence is where you're just adding the same number each time. And that number can be positive, that number could be negative, that number could be a fraction or a decimal. But you're adding the same value each time. And the value that you add each time is known as D. D is called, and I'm going to write it down here, the common difference. The common difference here, what are you just doing each time? You're adding 3, so D equals 3, done. In general, how can you find D? You could find D by taking any term minus the previous term, which is also written here, any term minus the previous term. So if I take 7 minus 4, I'll get 3. If I take 19 minus 16, I'll get 3. If I take any term minus the previous term, I will get the common difference. As far as the formula for a particular term, it is right here, but I personally write it a different way. I take the first term, which is a sub 1. A sub 1 is the first term. And a sub n is known as the nth term. And I do d times n minus 1. I know tomato, tomato, potato, potato. I just happen to write it that way because it seems to make, you'll understand, a little more logical sense when you write it that d times n minus 1. And why times n minus 1? N happens to be the term number. So if I want to find, let's say, what is 22? 1, 2, 3, 4, 5, 6, 7. So if I want to find the 7th term of this sequence, apparently I'm starting with the first term, which is 4. And then how many extra times must I have to add 3 to get to 22? Well, I'm already starting with 4. So how many extra times do I have to add 3? 1, 2, 3, 4, 5, only 6 more times do I need to add 3 to get to the 7th term. Why? Because I'm already giving you the first term to begin with. So when I start with the first term, I add the common difference n minus 1 times instead of n times. That's the big thing right there. And then to find the sum of the first n terms of an arithmetic sequence, thus the series, I take the number of terms divided by 2, then I take the first term plus the nth term. Okay, we're going to deal with both of those formulas in this lesson. Let's get to it. Find the 25th term of an arithmetic sequence if the first term is 2, the common difference is 3, and so they're basically working it all out. So to find the 25th term, and I'm going to write it in my own form, I'm going to take the first term plus the common difference, and then 25 minus 1, or 24 times. Always one fewer times than the term you're finding, you get your answer of 70. Same thing, whether it's 3 times 24 or 24 times 3. By the way, it really does not matter. This happens to be my personal way of writing it. If you want to follow, you're going to be tragically honest, this is the formula that you're going to find in the book. n minus 1 times d. I prefer d times n minus 1. Like I said, it does not matter. Okay, find 3 arithmetic means. How do you find an arithmetic mean? All right, between 4 and 15. Well, we all know how to find a mean. You add and divide by 2. But what if we want to find 3 of them? So I'm going to write this problem all over again. So I'm going to write the first term 4, then 3 empty dashes because we're finding 3 means. So basically, we need to find what the spacing should be. And what number describes the spacing between? It's the D. So we're solving for D. So what I personally do is I personally write the formula out. A sub n equals a sub 1 plus d times n minus 1. The nth term is also known as the last term. So 15 is the last term, so that's the nth term. The first term is 4. D is the spacing that we're trying to find. What is n? N represents the number of terms, including the dashes. So I'm going to use a different color for this here. So there's 1 term, 2 terms, 3 terms, 4 terms, and 5 total terms. The dashes and the 4 and the 15 are 5 total terms. So it's 5 minus 1. Okay, because there's 5 total terms. N equals 5. Okay, and if I'll just go back to red just to finish this problem up. And then if I work that through, that's exactly what's over here. So 15 equals 4 plus 4d. I guess that's why they do n minus 1 times d, right? Especially if you're solving for d, it makes sense. And d equals 11 over 4. So then you have to, you're not done yet. You found out what d is. Hey! But now you need to find the missing thing. So 4 over 1 equals 16 over 4. And 16 over 4 plus 11 over 4 equals what here? 27 over 4. And that is the next term right there, 27 over 4. And 27 over 4 plus 11 over 4 is 38 over 4, which reduces to 19 over 2. Keep it as 38 over 4. 38 over 4 plus 11 over 4 is 49 over 4. Okay? Questions? Of course not. This is a video. I can't speak with anybody. Next example. If you are having confusion, pause, rewind, replay. Find one arithmetic mean. Now hold on. If you're finding one arithmetic mean, yes, you could do this, but just do this. If you're finding one arithmetic mean, that's just finding the average. So 24 plus 7 is 31. 31 divided by 2, that's it. That's your mean. When you're finding one mean, that's all you have to do. Given the sequence, and this is a colon, it's not a negative. 9, 13, 17. All right. So right off the bat, d equals 4. I'm just going to submit that right now because it is. Is 137 a term in this sequence? If so, which one is it? If not, why not? So what I'm going to do is I'm just going to write the arithmetic formula. A sub n is a sub 1 plus d times n minus 1. If 137 is in the sequence, it would be, let's just say it's the nth term, 137. The first term is 9 plus, we know what d is 4. What we don't know is which term 137 might be. So this is this. So you can distribute the 4, simplify. If n is a nice pretty whole number, then the answer is yes. It's in the sequence. If you find that n is not a nice pretty whole number, it's a fraction, then no, that term is not in the sequence. So if you get a whole, say this whole number, yes. Not a whole number, then no. Done. Given an arithmetic sequence where the 5th term is 14 and the 16th term is 47, find the first 4 terms of this sequence. All right, so there's 2 ways we can go about doing this. One involves systems of equations, and one involves just going straight away with this. I'll even do the systems first. All right, so we know that the 5th term is 14. So 14, it involves taking the first term, which we don't know, plus the common difference, which again, we don't know, 4 times. And we have to add it 4 times. Why? Because we're getting to the 5th term. Remember, it's always 1 less than the term you're trying to find. 47 is the 16th term. So you're taking the first term plus 15 times the common difference because it's the 16th term. Then solve it out. You can subtract them. Negative 33. The addition method, or in this case, the subtraction method, is negative 11 times d, and you'll get d equals 3. And once you find that d equals 3, you could work your way backwards. If you're adding 3 each time to get the next term, then technically you're subtracting 3 each time to get the previous term. Does that make logical sense? So if the fifth term is 14, that means the fourth term must be 11. Going backwards, the third term must be 8 because you're subtracting 3 each time to go backwards. The second term must be 5 and the first term must be 2. That's one way to do it. Another way is to think how many terms are there in between 5 and 16, including 5 and including 16. And I'm going to go on camera for this. Count it with your fingers. You might think 11, but really it's 5. You have to include the 5. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There's 12 terms from 5 to 16 if you include the 5 and you include the 16. So I start with 47 as the nth term. I start with 14 technically as the first term, but then there's 12 total terms, so 12 minus 1. So then I solve it through, and I also get that d equals 3, and then I solve it backwards the same way. So you have two different ways to solve a particular problem that looks like this. Okay, 2 examples left, and then done. Find the sum of the first 6 terms. So the sum means the sum formula, which was the S sub n equals n over 2. And then I know on the front it says A1. I'm going to write A sub f plus A sub n. All right. And so A sub f, instead of saying 1, the first term, I always like to write the first term. In this particular case, it's not going to matter as much as it will as in example 7. I'll explain what I mean. So we need 3 variables here. We need to know n. We need to know the first term, or the first term in the sequence. And we need to know the nth term. It's the first 6 terms of the sequence, so n equals 6, done. We know the first term. It's 5. That's right here. But what we don't know is the 6th term. So before you can plug into this formula, you need to find a certain piece. And this is where a little side work comes in. It's like a little side work right here. And the 6th term is 40. Once you have all 3 pieces of the puzzle to this formula, you simply plug and chug, plug it in, plug it in. So where did this 3 come from? It's 6 divided by 2, which is 3. And then 5 plus 40. So 3, and then 5 plus 40. 3 times 45 is 135. Done. So I like to be neat and organized about this. I like to list all the variables that I need. Sometimes you need to do a little side work to find one of the 3 variables. And then you could plug into the sum formula and find your answer. Okay. Last but not least, example 7. This is the sum. So I know Mrs. Middleton wrote this. I'm going to cross all this off. Here. You might, the book or your worksheets might not even have that there. It might just say find the sum as I goes from 1 to 50 of 2i plus 1. Okay. I need to know 3 things. I need to know the first term. I need to know, I guess, the last term. And I need to know n. And in this case, the first term is a sub 1. Why? Because 1 is the small number there. The reason why I don't just say a sub 1 right off the bat is, what if this went from 2 to 50? Or what if this went from 3 to 50? Technically, the first term, if this went from 3 to 50, technically the first term would be a sub 3. Do you follow what I'm saying there? It's very important to know what your first term is and what you're plugging in to find the first term. The last term would be a sub 50. Why? Because that's the number on top. N is sometimes tricky. How many terms are there from 1 to 50? Now let me come on camera one more time. How many terms are there from 1 to 5? Some might just say, just do 5 minus 1, it's 4, Colodi. No, you got to start with 1. How many terms are there from 1 to 5? 1, 2, 3, 4, 5. There's 5 terms from 1 to 5. So technically, you could take the top number, and I'm writing this now, minus the bottom number, and then add 1 to it. Why? Because you are including the bottom number and the top number. So there are technically 50 terms from 1 to 50. Okay, and I am going to punch back out so you don't have to look at this mug again. So the first term is just 2 times 1 plus 1, which is 3. I don't know why I wrote that last parenthesis there. Let me see if this erases as well. Yep, all right, good. And then to find the 50th term, it's 2 times 50 plus 1. 100 plus 1, which is 101. Hey, once you have all 3 pieces of the puzzle, you plug them right in. 25 is found by doing 50 over 2. That's how you get the 25. Times 3 plus first term plus last term. You get 2600 as your answer. That's it, everybody. Arithmetic sequences. All right, if you have questions, ask. Bye, everybody.